This is ComputerSystem T222. So in this question we're looking at idle times of CPUs when executing tasks. So the table below shows the priorities of 3 tasks together with the operation sequence and the processing time of the CPU and I/O device when each task is executed in a standalone mode. So this is going to be shown on the next slide, and we'll have a little go over what each of these points mean. What is the idle time in milliseconds of the CPU from the moment when all 3 tasks become ready to execute simultaneously until the execution of all 3 tasks is completed? Here there is no I/O contention or in-out contention, and the overhead of the OS can be ignored. In the table, the number enclosed in parentheses or in brackets shows the processing time for each operation. So here we have the table described on the previous slide, in which the operation sequence is shown on the right here, and the priority is shown on the left here in table fashion. So we've got a high, a medium and a low priority sequence of instructions, and we've got the sequence of instructions. The brackets, as we mentioned, represent the execution time in milliseconds of each instruction. So what is the CPU idle time in milliseconds? Is it 1, 2, 3 or 4 milliseconds? This question deals with the idle time when the CPU is not operating during the concurrent execution of tasks. First of all, the CPU and I/O processing times of the task need to be drawn as below. This is shown on the next slide. Different colours have been used for visualization of the task execution process, so it's easier to see when the CPU is going to be idle. The idle CPU time can be obtained from the table on the next slide. So firstly, let's just look at the high priority task, and let's see where the CPU would be idle in this case, so we can work it out for the full diagram. So first of all, the 3-second CPU task is activated, the 3 millisecond task. Then we have the 5 millisecond input-output task activated, and then finally the CPU is reactivated for a 2 millisecond task at the end. So these operations, if we were just focusing on this operation, we would see that between the 4 and 8 slot would be idle, so we'd have 5 milliseconds of idle time. However, we've also got to take into account our medium and low priority tasks. So when we finalize the drawing that we have here, what we can see is in the sections 7 and the section 8 and the section 11, we have an idle CPU, i.e. it is not being used for CPU operations. These are purely I/O operations. Therefore, if we add up all the time slots here, we gain 3 milliseconds of idle time. So our answer is going to be 3 milliseconds as shown here. So finally our answer can seem to be C. So in this video we've had a look at CPU idle times when performing concurrent operations.